First of all, the test. First 3 questions are exactly that. They're questions. You're gonna get out of here. You're gonna actually have to. You're gonna actually have to answer questions about the notes. Like, for example, what is a voltaic versus an electrolytic cell? What are the parts of the cell? What is the half reactions? What does the salt bridge do? All these things, and explain them in terms of that I gave you in the notes. So you're going to not just be able to do math problems on this and get away with it. You have 3 questions. They're going to be short answer. They're going to be maybe 1 or 2 sentences it'll take to answer, not essay questions. 1 or 2 questions, 1 or 2 sentences. The next 3 questions, next 3 problems are problems just like these. All right, right here. The conversion ones, the kind you're going to have to get to moles or grams or amps or whatever. All right, I'm going to do 2 of them on the board. Now the back side, as you can see, I've actually drawn in here some cells for you to fill in. I'm not going to do that today because, unfortunately, all the pictures I have that are like this can't have a black background. And, of course, when you do that on the video, it doesn't show up very well. But I will have, actually, on your test, things that look like this, okay? All right, like this one or like that one. And then all you'll have to do is label the parts of it. Like this is zinc, and this is zinc ions, that's a salt bridge, and this is a voltmeter, and whatever. You have to label everything, and I'm going to go over all the stuff you have to label. So there are 3 of those in the back, okay? So let's go through it again. There are 3 of these kind of questions, 3 of these kind of questions, and 3 actual questions where you have to answer in full sentences stuff about the different things, about the cells. All right, or electricity or electrochemistry in general. But it's going to be mostly about the voltaic cells, the electrolytic cells, the difference between them, and the parts of them. Okay? All right.
That's really smart.
So you have to actually study for this. You can't just hope, oh, I understand how. Let's face it, these should be the easiest. It's just using knowledge from Chem 1, how to do conversions. Even if you didn't understand these problems, you would be able to do them just from the units. All right, following the units. That's how I'm going to show them to you today because we've got to do them quickly to get through. All right. Problem like this first one. You have, you're told you have 15 amps for 20 minutes. Okay, with zinc solution. I wouldn't, you should really write out the equation. Zinc with a +2 is adding 2 electrons to become zinc metal. All right, and in that case, that just tells you what when we need it. How many what? Equivalents. It's going to tell me how many equivalents per mole there are. All right, let's start out. What do I want to start with? I want to start by 15.0 amps. Now, 15.0 amps. Oops. I want to erase it. 15.0 amps is 15.0 coulombs per second.
We just started.
Yeah, you could just start it with coulombs per second. I'm just showing you that today. All right, I'm not going to be able to fit it all on one line. You should on the test. I have a smart board. I have to write this big for you to see if it's not going to fit on here. Okay, but yours can. I want to take care of the time element first. So I have seconds on the bottom. I want to put seconds on the top. And minutes on the bottom. 1 minute contains 60 seconds. They cancel. How many minutes do I have? I don't need a line here. Just 20.0 minutes. Okay? Minutes cancel. I've now taken care of all the time parts of it. All right? I'm now in coulombs, which is nice because I want to eventually get to grams. Now, that's coulombs is a physics or an electricity term. I want to get to a chemistry term. I got to get there. How am I going to do it? Well, even if I'm confused, and I'm sure some of you are. I'm sure Dayton is because he hasn't even started them yet. Dayton, what's going to go on the bottom?
Cool.
Exactly. It has to go on the bottom just because I got coulombs over here on top, it's the only unit left. And now I think, and of course, here's where there's always some memorization. I actually have to know. I actually have to know how coulombs are related to some other unit. What are they related to? Faradays. 1 Faraday contains 9.648.7 coulombs. I told you I would give you that number, but most of you probably know it already by now from using it so much. Okay. So now I've converted out of coulombs into Faradays. So why would I want to do that? Why? Because Faradays is my link to chemistry. All right. I'm going to have to continue it over here. Faradays are going to go on the bottom and what on the top? Equivalent. Yeah, so there's my link. 1 Faraday contains 1 equivalent. That's always going to be the case. You're going to get sick of writing that, all right, because that's going to be in every one of them where you're converting from physics to chemistry. All right, now I've got to convert from now I'm totally in chemistry. equivalents to moles. We've done this before. 1 mole contains 2 equivalents. I erased it, but that was a zinc plus 2. In fact, it needed 2 electrons. Equivalents cancel. And then finally, moles to grams. 1 mole contains, for zinc, 65.39 grams. And I don't really care what the answer is, but it should be in units. Why don't I care? Because here's how I'm going to grade it. 2 points, 2 points, 2 points, 2 points, 2 points, 2 points. All right, so probably worth about 2, 4, 6, 8, 10, 12 points plus 1 point for the answer is about 13 points. Remember, you don't have a whole lot of problems on here. You got a total of 6 problems on here. All right, each one's going to have to be worth quite a few points.
What about the answer problems? How are they?
Well, they'll probably be not worth. They're not going to be worth 13 points. They'll be worth maybe 5. It's a bit whatever I need them to be worth to make it worth 100 points. All right. So, but they won't be worth the amount of these problems because you have so many things to do. Think about the ones we're going to do in a minute. We have to do all that, and the anode, cathode, oxidation reduction, electrons, balance, all that stuff. Each one of those worth a point or 2, depending on what it is. All right, now this guy right here, what are we going to do with him? Here, I'm kind of working backwards. This time I'm given the mass, which is a chemistry thing first, and I want to get to, well, I want to get to time, which is really neither, but it's part of the physics thing, the electricity thing. So here's one of my clues here. I realize that I'm looking for time. The unit that has time, I want to end with time. The unit that has time in it is amps. So I don't want to start with him. I want to end with him, right? So, because he's got amps or coulombs per second. So let's start with the 0.397 grams. Again, I should do the Ag with a +1 is becoming Ag0, and that takes 1 electron. So that's going to be important later on to do the equivalence. But anyway, I'm going to start with 0.397 grams. Now, I know even if I'm confused, everybody's going to be able to, you're not going to leave these blank. You know that grams have to go on the bottom. You know moles have to go on the top. You can't do anything in grams. You got to get them into moles. Silver is 107.87, and I've got myself into moles. Now, moles will go on the bottom. I know that. I'm following the units, and I'm going to go to, I took care of how many electrons I have equivalent to the top. 1 mole contains 1 equivalent in this case, which is nice. Now I've got to decide, now I've got to use a little knowledge from this chapter. I mean, before this chapter, you would not have known that equivalents and Faradays were equivalent. But 1 Faraday contains 1 equivalent. They're the same basic idea, which is the physics versus chemistry. Now that I've converted into Faradays, I'm set to get into my chemistry, or physics I mean here. So Faradays on the bottom, coulombs on the top. 1 Faraday contains 96487 coulombs. All right, now I'm almost out of room here. Probably should have written a little bit smaller, could have fit this in here. Because here's the last one, and it's a biggie. All right, I have coulombs. I want time. Amps are coulombs per second. I know coulombs have to go on the bottom, and seconds have to go on the top. The weird part about this is it's 1.4 is on the bottom. It's actually upside down per second. 1.40 coulombs per second. It's like amps inverted, okay? And that will give me my answer because coulombs will cancel, and I'll be left with seconds. What if I wanted it in hours? I'd have to then continue and do seconds to minutes, and then minutes to hours, and then hours to yours, and yours to mine. Okay. All right. That's the end of those guys. Now you're going to have 3 of those in the test. Let's look at this one here. I give you these observations. I will give you, and this is a real gift, honestly. I don't have to do this, but actually, there's 2 reasons I do it. One is I'm a nice guy. But the other one is, probably more importantly, is it's easier for me to correct. Because when you guys draw stuff, you really draw it crappy. Like people will try to draw it this big. You know, they're trying their electrodes, and I have no idea what they're drawing. All right. So I have for you drawn already a generic electrolytic cell. Now that's a real gift for this reason. You should know an electrolytic cell has a battery on the top, is only 1 container. Like you're going to draw 1 container, not 2. You're going to have the electrodes both in the same solution, okay? And this is going to be a battery up here, not a voltmeter. That's all stuff you should be able to do on your own. But I'm going to have that generic thing drawn for you on your thing. And you just have to label on either side, like I'm going to do right here, what each of those things is. What each of the electrodes is, and where the electron flow is going, and all that stuff. So let's start. I don't care which one you call A or B. Let's just take a look at this guy right here. This guy is, we'll call him the one where fluorine gas is produced. All right, if I've got fluorine gas produced, remember in my solution I've got calcium ions and I've got fluoride ions. Everybody good with that? So where did those fluorine gas that's produced at electrode A come from? I know I got F2. All right, it must have come from F minus 1. All right, I should have written that a little bit differently. All right, it had to come from F with a minus 1. F with a minus 1 is becoming F2. In order for that to happen, I got to balance it for mass. And how many electrons are lost or gained? Those are lost. Okay? Let's look what's happening on the other side. You might think you're going to find on the other side calcium metal form. That would make sense. But unfortunately, you don't. Because calcium is going to be harder to reduce than the water is. So the water actually is where that hydrogen must be coming from. Because I know, again, I'm getting hydrogen gas over here from something. I'm also getting a basic solution, which is OH minus, right? So that's how much I know. What must have happened in order for that to happen? I put a 2 in front of there, balance them out, and I'll need 2 electrons to make all that happen. Everybody got that? I noticed same thing happened in the other class. At this point, people are writing. I could always tell when you guys what you're going to get wrong on the test just by watching in the review day. If you didn't know that, and I obviously in the other class and in this class, over half of you didn't in both classes, then you got a problem. All right, you have to be able to understand. You have to be able to interpret the observations to see what's going on there. Sometimes the calcium, all right, it won't be calcium, it'll be sodium or something like that, will actually form a metallic sodium. Then it's just going to be Na is becoming Na metal and whatever. All right. Sometimes the water will form hydrogen. Sometimes the water will form oxygen. It'll be selectively oxidized. So you have to be able to tell from the observations which is happening. Now, I did an example of each type. I did an example of molten sodium chloride, where sodium is formed at one and chlorine is formed at the other. I did aqueous sodium chloride, and I did aqueous sodium sulfate, where you've got both of them. Water is selectively oxidized and reduced in both sides. You have to be able to know what's happening, because otherwise, the rest of this stuff, once this is down, let's face it, it all flows from there on. We know what this is. What's that? Oxidation, because he's giving off electrons. We know what this is. What's that? Reduction. Red cat. Everywhere, anywhere you do it, the cathode is where reduction is occurring. The anode is where oxidation is occurring. No one's going to get that wrong. You look at what happens. The electrons are formed here. They're going to travel this way. You could tell me the way the electrons are flowing pretty easily, can't you? All right, because the electrons will take the path of least resistance. They're going to go up the wire and come back down here to be used to reduce this guy. All right. You're also asked what kind of a cell this is. This is an electrolytic cell. There's only one problem with this. All right. There's only one problem with this whole thing, and that is remembering which one's the cathode and which one's the anode. What's that?
You mean positive.
I'm sorry, my fault. Exactly. The only problem is remember which one's positive and which one's negative. So in this case, for an electrolytic cell, which one's positive?
Oh, no, the anode.
Now, that's going to be a problem because all you're doing is memorizing it. And the next example, I mean, somebody said, I forget exactly what they use for their, I'm trying to think. I think they said, well, again, it was their own little mnemonic device. Voltaic ends in, electrolytic ends in that thing too. I don't know what they were thinking. Red cat's an easy one to remember, reduction in cathode. I told you the way I remembered it. I remembered which one's going to be positive based on the voltaic cell we did in the lab. Okay? In the lab we did the voltaic cell. You may remember the voltaic cell was positive. The copper side was positive. Remember, I think of that because copper's red and the red wire is always positive. What was copper doing in that? He was being what? He was being reduced. Okay, so in a voltaic cell, the reduction is positive. In the electrolytic cell, the oxidation is positive. But that's just me. I mean, I have to think about things. I don't like to memorize it because the fact is you'll find some stupid way to memorize these. Some of you will. All right, and you'll get it right. 2 weeks from now, you will not remember it. Okay, pneumatic devices only work for a short period of time. They're not going to work forever. Certainly not going to work 2 years from now when you're taking electrochemistry. All right, so that's why I don't really enjoy doing these that much. I know that this stuff will stick with you. Everybody should be able to write an oxidation-reduction reaction and tell whether it's gaining or losing electrons. All right, we got to hurry because we have one more to do.
That's right.
All right, so let's do this one here. All right, this guy is going to look a lot different. He is a voltaic cell. You know he's a voltaic cell because it tells you a current is produced. So because of that, you're going to draw two things here. Your salt bridge here. You're going to have your electrode, and this time it's not a battery, it's just a voltmeter. Okay? And let's do each cell, or let's do each side. This is the salt bridge. You need to label that. Label the salt bridge. You also need to label each of these containers, what's in them. Okay? This electrode is going to be, it says aluminum and silver electrodes. We'll call this guy the aluminum electrode. We'll call this guy the silver electrode. This will have ions of aluminum in them. And this will have, that's +3 ions. This will have silver ions in them, +1 ions. Okay? You have to label all this. I'm not going to have that labeled. Also, you have to label what's going on. And how do I know what's going on? This is the key. We're almost out of time, but this is the key for how we know what's going on. I've got to look up aluminum and silver on the standard electrode potentials. You've got to look those up. Who's more positive on that chart is going to be the guy who is reduced. Who is more positive on that chart? Silver is more positive? Did you look that up? I didn't notice this time. I didn't tell you. I did not tell you the observations. Like silver metal is formed here or something like that. So you have to look it up. Now, you all agree that silver is more positive? Is that right? Yes or no?
Yes.
Can you find it on a chart for me?
Yeah.
Okay, so silver is more positive. So that means he's going to be reduced. It goes from Ag with a +1. He's being reduced with 1 electron to Ag with a 0 charge. That means if he's being reduced, the other guy must be oxidized. We have Al with the metal becoming Al with a +3, and he gives out 3 electrons. To do that, what do I need to balance these guys? 3. Right? Got it? All right, secondly, this is this is oxidation, and this is reduction. Don't get into your head that oxidation is always on the left, reduction is always on the right. It just happened to work out this time. All right. This is the anode. This is the cathode. That never changes. But something does change. All right, positive and negative. Where's the positive this time? Okay, and the negative's over here. There's something else I have to do on this one that I didn't have to do on the other one. Oh yeah, the electrons too. The guy who's giving off electrons are right here. He's going to go up that way and down that way. Okay, good. That's the electron flow. And I have to call this a voltaic cell. One thing I have to do here I did not have to do in the other one. And what's that? What's that?
Add them together.
Yeah, got to get the voltage. So if you look up on that chart, silver, what was his number? 0.80. And if you look up the other guy, he's what? Negative 1.6, which I changed the sign. I have 1.6, what was it? 6. And then I add the two together, and I get 2 point whatever. 46. All right? And that is the voltage you would put down. Probably, I don't know how I did it in the test, but I might have even left a room for it up there for the voltage, okay? All right, so you need to study and be able to do these problems.